So I've created a new IntelliJ project and called it Threads. So go ahead and do that. And of course, this is just a basic console application. So we just put in a simple printout here. Hello from the main thread. And we run that. Of course, you've seen something similar a million times so far in the course. And we see the output. And this is the application running our code on the main thread. And obviously that includes the code in the main method that we've just added to with our system.out.println. So let's make this a little bit more exciting. Let's go ahead and create a thread. So we can do this in two ways. The first way is to create an instance of the thread class. But let's think about what we want to do first. What we're trying to do here is to kick off a thread that's going to run some code. So we need a way to tell the thread what code we want to run. And we're going to do that by creating a subclass of the thread class and then overriding the run method. So rather than creating a thread instance, we're going to create an instance of our subclass. So let's create the subclass first. So we're going to come over here to our source folder. And I'm going to right click that and create a new class, and we're going to call that one another thread. So we need to override the run class, but before I do that, I need to extend from the thread class so we get access to those methods. So we type extends thread being the superclass, and now we can override. We get the additional options, so we're going to select the run method. That's the one that we want to override. And we're going to remove the super.run because what we want to do is put the code that we want executed. So in this case, we're just going to print out another console message. Hello from another thread. Really basic. So now that we've done that, let's switch back to our main class. So after the main thread writes the console, we're going to now create an instance of the another thread class based on the class we've just created. So to do that, we type thread, another thread is equal to new another thread. I'm going to put a space there so we can see it a bit easier. And when we do that and run it, we still only see the output from the main class, and that's because we've defined a thread, but we haven't invoked the run method yet. So we need to actually invoke the run method so that it executes for us. Now you might be thinking, okay, how do we execute this? Do we use the run method? Well, in actual fact, we use the start method. So to another method .start, and what that does is enables the JVM to run the run method for the thread. And if we run that, we can see hello from another thread. So clearly the thread has now run and executed the code that we defined in the run method. So again, it's important here to remember that we have to create an instance of a thread, which we did on line 8, but then we also have to start the thread independent of that, which we did on line 9. So let's now print something from the main thread after we've started the other thread. So after line 9, we want to print out a message, hello again, from the main thread. So let's run that. And you can see we've got the output on the screen. But remember at this point that when we run, we might see the second line from the main thread printed before the line of the other thread. And this is going to vary, so we might have to run it a few times to see that this happens. But if we run it again, run it a few more times, we can never assume it's going to run in the same order. And it really does depend on the timings, how long a particular thread takes to run. So in this case, it's fairly consistent given that it's just outputting. But what we can do here is when we're dealing with threads is keep in mind that it's up to the system to schedule when the threads will run. And in relation to that, we can influence the order of execution by setting a particular thread's priority. But even with that said, we can never assume that threads are going to run in a particular order. So keep that in mind that although here it seems to be very consistent with I'm running it each time and we're getting the same output each time, that isn't guaranteed because ultimately the decision for the priority in terms of which threads are running, even though we can influence it to a degree by setting a thread's priority, it's up to the system itself to schedule when those threads will ultimately run. Now, rather than creating a named class for the other thread, we could also have created an anonymous class. And this is useful if you're only ever going to want to run the code once. In that situation, an anonymous class would work and is probably easier to configure. But if you intend to run the same code several times, and creating a class for the thread like we did with the another thread class would make more sense and be a better result. But notice here that I said run the code several times and not start the thread several times. The thing to keep in mind here is we're not allowed to start the same instance of a thread more than once. So in other words, if you create a subclass of thread and you want to execute the code in the run method more than once, then what you have to do is create a new instance of the subclass every time you want to run its main method to execute. You can't start a thread instance that is already run, in other words. So let's try starting the instance of another thread again just to show that it won't work. We should actually see an exception if we try and do that. So we'll go ahead and add the code to do that. So we type another thread dot start again. We should see there's an exception when we do that. And you can see we have got an exception on the screen, illegal thread state exception. So again, using a subclass of thread means that we have to define the run method once, but we can't reuse the same instance. So we'll delete the second start so we don't see the exception again. So let's do that now, delete line 13. But getting back to anonymous classes, when we use an anonymous class, we have to start the thread immediately. So that's another consideration when deciding whether to use a named or an anonymous class. And of course, the named class is the one that we've already defined using the another thread class here. So let's create another thread as an anonymous class and have it print a line to the console before the main thread prints its hello text again, or hello again text. So I'll come down here after the first start, and then we'll type new thread. And this is the way to create an anonymous class. And it's going to be public void run. And the output is going to be hello from the anonymous class thread. And then after the closing brace, we do start.start and select it that way. So if we run that now, you can see that's now working with the anonymous class. And again, just to note that the only thing we know for sure is that the first line we see in the console will be the first line printed by the main thread. We can't guarantee that execution order. So if we try running it again, and you can see what's happened here, hello from the anonymous class thread, that's outputted after the hello again from the main thread, and this is what's happening with the thread. So we've created a thread and we've used .start to run it immediately, but because it's a thread that runs in the background, the way that the system, my computer, has scheduled things is that it outputted the hello again from the main thread before the new thread from the anonymous class got to execute. And that will depend on your computer. You may get a similar result or you might get a different result altogether. So basically I'm saying is that may vary from time to time, even though it seems to be pretty consistent with I'm running it here now. It's likely that on other computers you'll get different results. And obviously in this case it's a short, very trivial example, and it's possible as a result, because we're really not doing much in the way of processing in these threads that we're creating, that the order is pretty much going to be the same each time you run it on your computer. But the point is, it may not be the order in which we created the threads, and indeed that is the case here, because in my example we created the anonymous class on line 11, and yet that code was executed after the system output was printed out on line 17. And again, this may be completely different when it runs on your computer. So we can't guarantee the order that the threads are going to be executed, or in which the print statements ultimately appear here. Again, I'm hammering on this a little bit, but I want to hammer home that we can't guarantee the order in which threads will execute. And that's one of the main reasons why working with threads can be tricky for you to work with, especially initially to get your head around the concepts here. So let's now adapt what we've done to make it a little bit easier to see at a glance where the outputs in the consoles are coming from. A good way to do that is to give each thread its own color. Now, the method we're going to use works with the IntelliJ console, but it might not work with another IDE console or within the Windows native console, because we're going to be using Unix escape code. So if you're using something other than IntelliJ, you may not see the coloring, but just try it and see what happens anyway. But in any event, you'll see the colors on the screen in this video anyway. So I'm going to create a new class here. I'm going to call this class thread color. and I'm going to paste in some code. Now, I'm not going to type this code in because it's really only some constants, and you can grab this text file in the resources section of this video and be able to do the same thing. And you did see something similar in the file input output section in any event. So in order to use these colors, we need to append the color code that we want to use before the text that we're outputting. And once we've set a color, that color will remain in effect until we use another color escape code. So if we want to return to the default code, we append rather, the ANSI_reset, which will set it back to the default color. So let's have the main thread use purple, the named one use blue, and the anonymous thread to use red. And if you want to, you could change that to black, but bearing in mind, depending if you're using the dark theme or not, you might find that it's not viewable. So I'm choosing colors that should work on whether you're using the dark theme or just a regular theme that comes with IntelliJ. So looking at the another thread coloring first, we'll click into that. And I'm going to add here ANSI_blue plus and hello from another thread. You can see that's automatically added the input there for the class we just created. So go back to our main class again. And we're going to add, again, depending on whether you're running a white background or the dark background. If you're running the white background, you might want to do it in black, but I'm running the dark one, so I'm going to use purple. So ANSI_purple. Plus, you can see that was added automatically. And then with the anonymous class, we're going to use ANSI_red. Perhaps we'll use green, it will look a bit better. Doesn't really matter which ones you use, so long as you've got a different one for each of the sections. So again, we've defined, looking back at another thread, we've defined blue for our regular named thread. And for the regular main method, we're using purple, and we're using green for our anonymous class thread. So if we run that, we can now see the outputs. We've got blue. So you might be wondering why have I got blue twice there? Well, what I didn't do is down here, I didn't specify a color. And by not specifying a color, it's used the color of the last thing that was outputted. So this was hello from another thread. If we go back to another thread, that was in blue, as you can see up there. So consequently, it used that because that was the next thing that happened to execute in order. So what I should really be doing here is making that ANSI, it's called purple as well, to guarantee that it's going to be outputted in the right colors. So now we should see the right result. So you can see that we've got now purple showing for our main method, the output from there, blue from the other thread, the name thread, and then a yellow from the anonymous class thread. Well, it's actually green, but to me it looks a bit more yellowy than green. The bottom line here is it's now a lot easier to see which statements are coming from which thread. So we don't have to read the thread, we can just look at it at a glance and look at the colors and know that that output has come from that particular thread. So change those colors as appropriate if they're a little bit hard to read. So long as you've chose a different color for each section, you'll be good to go. Okay, so I'm going to finish the video here now. In the next video, we're going to talk about implementing Runnable, which is a way to create threads using another method. So the Runnable interface is another way of creating a thread which really only requires us to implement one method. But in any event, we'll look at doing that in the next video.